Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to first of all thank Tableau for sponsoring today's event. As many of you know, Tableau is a longtime supporter of the Data Science Central community, and we are honored to have them sponsoring today's event. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including MapR, Teradata, Tibco, Pivotal, Hortonworks, and Databricks, to name just a few. All these webinars are available at datasciencecentral.com, and if you have not had the opportunity to view them, I would encourage you to take a look, as they really do provide some useful information. Today's webinar is entitled Best Practices for Using Color in Data Visualizations, How and Why. And before we begin, I'd like to briefly review the format for today's webinar. Today's event will be 1 hour long. We have a single panelist that I'll introduce to all of you in just a moment, and we should have about 10 to 15 minutes for Q&A following the presentation. And this webinar is being taped and will be made available later on this afternoon at datasciencecentral.com. I'd also like to encourage all our attendees to provide questions throughout the presentation. I will be reviewing them and presenting them on your behalf during the Q&A portion of today's event. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I'll be your host for today's webinar. I'm very pleased to introduce today's speaker, Maureen Stone of Tableau Software. Maureen is a research scientist with Tableau and is also a recognized member of the color and visualization research community and the author of the book, A Field Guide to Digital Color. Her research focuses on making color and other visual encodings more effective. Prior to joining Tableau, she worked first at Xerox PARC and then as a consultant under the name Stone Soup Consulting. Maureen, thanks so much for being with us this morning. I'm really looking forward to your presentation. In today's webinar, you will learn pretty much everything there is to know about using color in data visualizations. Maureen will describe best practices for using color in visual analysis, the visual principles that underlie them, and how these insights influence Tableau's products. You will see how different choices and settings can enhance different views and present different findings. You will also learn some of the fundamentals of color vision and what color blindness really means. All this in an effort to illustrate how color can make your dashboards both beautiful and visually effective. So Maureen, with that, I'm going to let the presentation go to you, and you can start whenever you're ready to go.
Thank you, Tim. Now, the summary sort of oversells this. Well, I can't really tell you everything about color and visualization all in 1 hour. Otherwise, what have I been doing for all of my life researching this stuff? But I will try to leave you with what I think are some of the key principles, both about color vision and the use of color in visualization. And I like to start these talks with a picture of color in nature to remind us that our visual system was designed to see color in natural objects. So here we have an apple tree, and then on it we have some apples, and the apples are color encoded to suggest that they might be ripe. Now what's really interesting, if you think about the technology involved, we're not looking at an apple tree at all. We're looking at a picture of an apple tree, and yet that picture has been encoded and is presented in little red and green and blue pixels in a way that tricks our visual system into thinking, apples. For data visualization, we don't think so much about apples, but we try to work with the visual system and not against it. So that's principle number one. There's a fundamental difference in how we perceive shape versus color. While we use our visual system to look at this apple tree, part of the information is all about the lightness, what we call the grayscale picture here, the lightness information. And the rest of it is sort of an overlay on it is the color information. I don't know how many of you have had the pleasure of hearing John Medina talk about brain rules, but he says that one of the fundamental rules, the very first thing when you see something that your brain wants to know is it going to eat me? And the lightness information really contains everything you need to know about that. It goes to a different part of the brain than the color information. Your brain reacts instantly to shape, shading, and motion. Color information comes in slower. It's more about the second fundamental question, can I eat it? Now in the visual system, we have the eye as the primary sensor. Light comes into the eye, so what we see is light. And in the eye we have 3 cells called cones that sit in the retina in the back of the eye. And their job is to encode this light into a way that the brain can interpret it. And what they send to the brain are 3 signals. There's 3 types of cones, and we get 3 signals to the brain. We get 1 signal for lightness and 2 for color. Psychophysics is all about how the retina encodes light. And I'm not going to go into that into any detail here. What I want to show, the point I want to make here is that even at the very fundamental level of vision, right at the back of your eye, we separate lightness from color. Now I'm going to flip over to a designer's view of color. Back when I was writing my book about a field guide to digital color, I started with psychophysics, and then I worked my way through all sorts of digital technologies, and finally ended up with design. And as I studied what designers knew and thought about color, I discovered it sort of wrapped around to the fundamentals of vision in a very interesting sort of way. And a lot of what I've been doing for the last decade or more in research is trying to do this blend of design and science so that we get the best of both worlds. So designers also have a view of color that has a lightness scale that's often called value, and then 2 signals. We have 1 signal, which is the hue, one aspect of color, most often associated with the name, red, purple, yellow, blue. And we have the chroma, or the intensity, or the purity, or some people call this saturation. Another very important design principle is called contrast and analogy. Contrast separates. It means something is different. Analogy groups. And when you do color design, when you do information design, you need to appreciate that those things that you want to pop forward need to have contrast with the rest of the view, and those that you want to remain sort of together need to be analogously colored. Now when I say color here, I can be talking about color in the sense of hue, like the example on the right with the red sitting over the shades of blue-green, so we can have contrast in hue. Or we can have contrast in lightness, which is what we see in the grayscale. So in both cases, the different ones, the dark ones, the red ones, pop forward and the rest sit back. If I asked you to count the red ones, you could quickly count up to 5. If I asked you to pick one of those particular blue-greeny colors and count it, you'd have to search carefully to actually be able to see it. And this is a principle that we can use in information design. So how do we fix this? Here we have a tangle of information all overlaid on one another. It's tempting to try to color it, to use color contrast to pull apart the 3 layers of information. But as you can see from this slide, lightness is what will really pull apart this information into visual layers. And this is probably the next most important principle, is to understand that controlling lightness, what you see in grayscale, is critical to design. As in human vision, the lightness is the critical information, the color overlays it. If you're going to make a complicated visualization of data, you need to have a clear visual hierarchy of what it is you're trying to show. And then you need to encode the information in this visualization based on this visual hierarchy. The first thing to do is to be silent, to throw out all the stuff you don't need. We don't need to introduce visual clutter into our visualizations. Then we whisper those things that are just context. We have sort of a medium indoor voice, medium shown by the medium gray here for the normal, and that leaves us room to shout out those special cases, highlighting, emphasis, alarms, sitting on top of this nice visual layering. The most common problem I've seen in digital applications is that everything shouts. So in Tableau, we've tried to apply this principle. I started working on coloring visual and other visual properties of the Tableau product back in 2004. I was consulting at the time, and then I joined the company just a couple of years ago as a full-time employee. So back in 2004, we said, well, we understand this. We're going to use gray for all the surrounding context, and the data will be blue. But as we got smarter, as we moved through the years, we discovered even that was overkill. Since what you want to see here are the numbers and the headers, that text is black or a dark gray, and everything else is faded out. It's just plain white. You don't need it. You don't need to indicate the area around the headers. And we even now have room, therefore, to give a little contextual information, those little shading lines to help you figure out which row you're on. This is even more important when you combine visualizations together in what we call a dashboard. Now we have multiple views. We have a text table down in the bottom, and we have various line graphs and a bar graph, and this thing looks very cluttered, a couple of legends. And look how much nicer it looks when we eliminate the unnecessary, when we put a better visualization information hierarchy on this. It's important that you be able to read your information, whether you mean read in the literal sense of reading text, like in this example, or whether you mean reading the glyphs and the lines and the bars and the other shapes that you're using. It's important to understand how legibility works. And here we can see that once again, hue contrast isn't doing it for us. It's the same yellow everywhere. All that's changing is the background gray. Instead, what we need is lightness contrast. So now I've gone ahead and make the yellow, it's just the same light color here. It's on the gray, and you should, at some point, you should be able to read this. The numbers down the side are metrics. There are metrics for contrast, and they're very useful when you're doing design, particularly if you're trying to automate design so that you don't have to eyeball this. The metric I'm using here is called Lstart. It's part of the CIE lab system, and it's defined such that one step is supposed to be a just noticeable difference. So these numbers are the difference with the background. The -1 means the background's lighter. Then we've got one where the background is just a little bit darker, and you can see as we step down the deltas get bigger, the contrast gets larger, and the text gets more readable. CIE Lab specifies color space in a perceptually uniform manner. And here's a place where design and science meet. Remember that we had the designer's view of color, which has a lightness scale, and then it has hue going around and chroma going out radially, as we see in the colored illustration on the right, the LCH. LAB was designed from perceptual metrics. It has a lightness axis, and it has two opponent colorings, plus and minus A and plus and minus B, which are color difference axes. It's a little hard to think in color differencing, but color differencing is in fact what your cones do. When I talked about them encoding the two color channels, they make these color difference. And what's most interesting to keep track of for later in the talk is note that one of those axes is red versus green. And it's weakness along this axis that causes the most common forms of color vision deficiencies. You can use CIE Lab to make contrast metrics. These are my rules of thumb. These are for fairly small text. The big yellow text was easily visible, I think, at about 5. But you really want to distinguish between, how readable does it need to be? What's your population? Do you have people with weak vision? Are you trying to do this just for 20-year-olds who have good eyes and are willing to spend a lot of time staring at it, or do you want it to be comfortably and easily readable for your grandmother? The ratios shown here are contrast ratios, which are the usual way metrics are shown for legibility or for even the contrast on your TV. I've created a relationship to Lstart here, and then metrics for to help me design how readable text, what colors the text needs to be to make it readable. The beauty of Lstart versus other kind of design systems is that the Lstart value is the perceived lightness. It doesn't matter what color it is. It is the lightness value that's going to control contrast. And Lstart, or CIE Lab, is available in Photoshop, GPIC, and many graphics packages nowadays. It's computed from RGB, and it does require calibration of your display to be exactly right, but we can use defaults. Now I could spend the rest of this talk trying to show you all this beautiful design in CIE Lab, but what I'm going to do is just leave you with the note that if you're interested in serious color design, then you need to learn about this system and explore with it. Now let's talk about another aspect of color other than its lightness. Let's talk about hue. So if I asked you what color these objects are, I think most of you would say, oh, the square is blue, the circle is orange, and the star is yellow. And if I asked you what color these objects are, you'd answer perhaps a little more slowly. The square is a blue-green. Is it teal? Is it green-blue? Is it cyan? The circle now is getting redder and darker. It's kind of bordering on brown. It probably depends on your display whether it looks orange, red, or brown. And the star, while still very yellowish, has now got a distinct greenish tinge. The relationship between color and language is an old and fascinating one. Berlin and Kay brought to the visualization community and the scientific community the idea of basic color names, but the study, the link between language and naming goes back much farther than that. If I ask you about color, you want to talk about it, what are you going to say? Are you going to give me a triple of hue, chroma, and lightness? Are you going to give me a triple of RGB values? No. What you're going to do is first start with a name. And these are the basic names that Berlin and Kay found studying language and the evolution of language for English and most languages similar to English, European languages. However, even within modern languages, these are not always true. We have, in Japanese, the line between green and blue is much less clearly defined, and I'm told that Russian has a couple of different shades of blue. Now, in Tableau, we try to take advantage of this basic cognitive link to color and naming by using as our basic colors, colors that have simple names. Even if it doesn't help you remember the color better, it makes it easier to talk about it. This is our Tableau 10 is our basic palette. It uses the Berlin and Kay names pretty much. We have, except that we don't use black, white, and gray. And I've added a blue-green color, which people sometimes call teal. And I don't have a good solid yellow. I have a gold. I have a dark yellow, which on displays looks greenish, and I'll talk to you more about that later. If you have up to 10 data items to color, we automatically give you these 10 colors. And if you have more, we give you up to 20 colorings where we do these in light-dark pairs. Now the advantage of basic color names is that it's pretty easy to call out the color of the bars. So if I ask you, for example, which bar represents bananas, I need to go over to the legend and I notice that we've colored bananas orange and apples blue, and then I have to go back and forth and look and make these correspondence. Now for something like bananas and blueberries, there's a semantic coloring. Is it better to use the semantic coloring if you have one? And the answer is yes. We've done some studies that indicate that, this was primarily work at Stanford I was consulting on, that indicate that people are just a little bit faster, just a little bit happier, a little bit better at reading their viz, excuse me a minute, if the color semantically resonates with the data, because our job here is for you to be thinking about your data, not about the color of your data. And so in this very simple case, you can come up with these kinds of encodings. Now, not everything will have semantically resonant colors, but if it does, it's useful to use them. So talking more broadly about visualization, let's talk about what the value of color is. Here's two views of a map. Once again, I've separated them into the lightness and in the colored view, lightness only and colored. Get it right in black and white is what the designers say. You should be able to read and use the map in the lower right corner, the grayscale one, but you should find the one in the upper left that's colored a little easier, a little better. And why is that? Well, because we've semantically colored a few things. The ocean is blue, the parks are green, and we've given the major roads a nice red color to help them pop out from the rest of the map. Here's another color example. This is from Netflix, and it's showing rankings based on area. It's a data map. And the ranked number one are the darker ones, which we can show in gray, or they're the redder ones in the upper left. And here, what we're trying to do with color is show you quantity, a ranking from maximum to minimum. And we're doing this by making a color scale. So the color on the colored ramp, those are analogous colors. They're basically all orange yellows. And you can see that the colors suggest quantity. They suggest a progression from max to min. And the fact that there's a little bit of hue shift in there just makes them more legible. You can read the map in the grayscale version, but it's just somehow not quite as easy. Back when I was first studying and thinking about how to talk about, how to understand how to use color in visualization, I went to one of the known visualization experts, Edward Tufte. And in his book, Envisioning Information, he talks about fundamental uses for color. So here's the next principle that's really important. If you're going to use color in visualization, you need to know what you're using it for. What is its fundamental use? What is its function? Don't just splash color around randomly. You actually have to have it for a purpose. And the first fundamental use is to label, is to identify or to group. This is what color does best. The second principle is to measure or to show color as quantity, like the color scales that I showed you. The third is to represent or to imitate reality. This is our semantic encoding. Tufte used a lot of examples off of maps. And the fourth may be a little surprising. It's to enliven or decorate. To make the viz attractive, to make it eye-catching, is a valid use of color in visualization. It just needs not to overwhelm the other functions. So let's see some examples from Tableau. In Tableau, we have ToLabel, which is the categorical palette. So here we have the various kinds of shipping containers that we might use for data from a superstore. And we use that to label the different dots in the scatter plot. In Tableau, once you color a data item, it stays that same color. And so the colors that I've designed have to be robust across all sorts of different visual types. So the same colors may appear in a text table or in a bar chart or in a scatter plot. And it's one of the challenges of designing for this particular application is because the color, how it's displayed, may morph, may transform as the user works. This is in contrast to something like a handcrafted visualization you might see on the New York Times website, where the color is applied specifically and carefully to that view and not to any other. Here's another example of a categorical coloring. In general, we recommend that you not use more than 8, 10, or 12 colors to label. The more colors you use, the harder it is to keep them distinct. But here's an example of using 27. And the reason it works, I claim, is because they're in order. We have this sort of rainbow ordering. They're in order by time. If I just mix these colors up randomly, they would be a hopeless mess. But because they're put in order and because this visualization has two parts, it has the hurricane overlays and then it has the timeline where you can see the ordering of the color, you can be richer. And in interactive applications, you can select an individual color and highlight it. And what we've done here in Tableau is we fade the colors back so that the one that you've selected pops out. We don't scream it, we whisper the rest. And that makes it easy to explore and figure out precisely which color goes where. In Tableau, we also use colors for quantity. We have these what I call quantitative ramps that map numeric data into color. And here's a data map. The larger the data, as you can see, the bar chart is showing the same information. If you wanted to see the precise relationship of the data, it's better to see it on bars than on colors. But if you want to tie it to the geography of the map, then we can do nothing better than color the states and get somewhat of the same sense. And this is sales data, so it goes from 0 to some maximum amount. This is profit data. It has both a positive and a negative extent around a 0. And in this case, we use a two-color ramp so that the profit is negative and the sale and the negative profit is negative and the positive profit is green. Boy, I said that badly. Look at the map. We have some states where we're positive, some states where we're negative. Again, the bars give this to you as a better view. So now I'm going to launch into the Tableau design principles and work my way towards a demo. We focus on visualizing data, not on color design. The goal is to see and understand your data. Another common mistake that people make when they get involved in information design is they get all involved in the coloring itself and forget about the information they're trying to present. In Tableau, we've tried to design it so you never have to think about the color design, just about the data. And to do that, we provide defaults that encode the best practices that we know. And part of my research is to continue to improve these defaults. We support multiple views and multiple mark types. And the UI design, we want to encourage best practices, but we want people to also have some opportunity to put their personal expression on it. For discrete data, where we want to do categorical labeling, we offer a set of palettes, like the Tableau 10 and 20. We have a lot of different kinds of palettes. And again, what I'm doing is running through quickly. Here is an overview, then I'll show you this live. We have the 10 and 20. We have a bunch of special palettes, including one for people who are colorblind. We have disjoint color palettes, which are like the Tableau 10 and 20, but only use part of the color space each. We have that cyclic rainbow ramp you saw on the hurricane data. And we have a bunch of ordered coloring ramps so that you can discretely color your colors in steps. And then we provide a way for people to make custom ramps, not ramps, custom palettes. For continuous data now, we have the ramps. We offer both one-color and two-color ramps and ways to control the color to data mapping. This can get very complicated. We tried to make it as simple as possible and yet flexible enough to cover most of the data choices that people need to make and views that they need to create. And again, I'll show that in the demo. Once again, we have many, many ramps in different colors for different purposes. We have light ones for behind text. We have sequential ones. We have diverging ones with different center colors. And we have some new ones that are default for large areas. Excuse me again. Because the perception of color is different depending on whether you're looking at a large area or a small size. All right, now for the scary part, I try a Tableau demo live. All right, it's green.
There you go. I can see it. You're live, Maureen. You're in good shape.
I'm live. I'm good. All right.
You're doing great.
So welcome to Tableau. What I've done is I've opened the product for visualizing data, and I have hooked it up to a Superstore database. This is a little toy database, but it has the type of data fields that you would expect from any retail operation. We have dimensions or categories, which are things like the customer ID and what state we sold in, the order date, the product in a hierarchy. And then we have the measures, which are the values, things like the profit and the sales. And the way we visualize in Tableau is we just bring out these data pills and we drag them into the view, and it automatically starts creating a viz. So here what we have now is a scatter plot. I have one dot on it, which is the sum of all the sales versus all the profit. Oops, I've got sales out here twice. Let's bring out the profit. All right, now we've got all the sales and all the profit. And I can now break this down. I can change the level of detail in this view so that I now can see the sales and profit for each and every item. All right. So how can I use coloring to help us understand this? I can take the department, which is the high level. I've got 3 major departments, and I can color, and it will now color all of the items that are in each of these departments. It's still a little hard to see much about individual things, but I can now see sort of 3 kind of clusters of data here. I could bring out a different level of detail and color it. These are categories. I've now switched. There's 18 or 19 of them, and I've switched now to the other Tableau palette with the up to 20 colors. And again, I can highlight and get some sense of where these are. And even more interesting, I can see these outliers, these orange guys, which are seem to be, there's a chair. Looks like those are furniture items. Let me show you a little bit about the UI. Let's go back to the department, and I can open up the color editor. There's our Tableau 10, and suppose that I want to do this instead of these kind of basic colors. I'm going to give it kind of an autumn theme. And now you can see these, those colors work too. They just look rather different. Suppose that I decide that if it's an autumn theme, I really need a yellow. So now we're going to go back to this issue of yellow. So I can go to the traffic light colors, and I can pick a yellow. And I can apply that, and it still looks kind of orangey. I know there's a real yellow on here. So I can actually get all the way down into the system color picker, and I can apply that one.
Maureen,
and now you see
just a moment. A few people are having a little bit of trouble, I think, seeing the live demo. It's coming through fine on my end. Anybody that's having a little trouble, you might just clear your cache. That should clear it up and fix it. But I do see the comments coming in. There are just a few, so most of you should be able to see it. If others are not, just send me a note, and we'll shift gears if need be. Sorry to interrupt, Maureen, but go ahead and continue.
Oh, that's important. I want people to be able to see this.
Yeah,
am I going too fast, Tim? I'm not watching the preview. I hope I'm not getting ahead of the demo here.
No, you're fine, and I have the preview on a separate screen, so it's looking fine on my end as a viewer as well. So I think it's just a few people are having some trouble. So I would say continue. But for those of you that are having any difficulty seeing the preview, 2 things: we are taping this, and it is coming through fine. And just try clearing your cache. So I'm sorry to interrupt. Go ahead and proceed, Maureen.
Okay, no problem. So here you can see the problem with yellow for data visualization, why we have that kind of yellow-green color instead. The yellow is too light. And I can say, well, that's all right. I'll go in here and I'll make it darker. And as I make it darker, look what it does. It gets green. And this is just a feature of yellow on monitors. And it's also an interesting concept about yellow as a color name. There's a very limited range of colors that we would call yellow, but there's a big range of colors that we would call green or blue. All right, back to data. Let's bring back the categorization, and now let's split this scatter plot up by category. It's really hard to look at 20 things in 20 different categories. And so what I'm going to do is break this into 3 separate scatter plots. And now I've sort of split up my data based on the hierarchy, but now the data, it still doesn't really help, right? The different colors are scattered all over this entire view. Could I do something to make the coloring more coherent? It turns out we can. If I bring out department again, and I change it so it also is on color, what we're supposed to do is automatically switch to a coloring that gives you a nice hierarchy. And it's not doing it. I love live demos.
Makes it interesting, huh?
It does. All right. One of the things that Tableau is very good about is it, once you've set a coloring, it remembers it. And since I was good enough to practice my demo in advance, it's remembering. Let's try this again. And voila. All right. So what have we done here? What I've done is I've taken the first item that I've colored, department, and colored it with one of the 3 basic hues. And then I've taken the second category and colored it with lightness. And now we see that furniture is all in shades of blue, office supplies are all in shades of orange, and technology is all in shades of green. And I think this is much easier to look at. The only thing that's kind of a problem is that we don't have very many shades of orange here that are very different from one another. We do provide you a solution to this, which were those disjoint palettes I was talking about. So I can take all of these shades of orange and now I can color them with one of our palettes that's like the Tableau 10 but only uses part of the color space. Okay, and now the problem is that we've got some green in there. That's now confusing us with technology. So let's go ahead and assign a different disjoint palette to that one. Okay, and so on. I'm going to show you another example of the hopefully without interference from the defaults, of the 2-level coloring. Let's bring out another field. We have here so what we have here is a tree map, and we have the sales on size, and we have each department broken down by region. So let's color also by region. And now we get our shaded view. So all of the technology ones are green, and then we shade by the 4 regions. Suppose we wanted to break this down so that we saw the different products within the context of region. Then we simply swap the order, and now what we have is not, again, what I expected. Man, I knew I was going to be brave to actually do this.
You're doing fine.
What we're supposed to see is a coherent chart by region. No. Heck with the tree map. The order is supposed to help you control the hierarchy and the nesting, and I've got something going wrong here. I'll get back to it if I have time, but I don't want to run out of the rest of the demo. All right, let me show you another use of coloring. I have these bars, and I've now dropped the container type onto the bar, and I've split each bar now by the percentage of the furniture that is shipped by, say, Jumbo Drum. You can tell different stories with different kinds of coloring. suppose that I want to emphasize just what's happening with jumbo drums. So here what I will do is I will assign a grayscale palette, and then I will highlight just the jumbo drums. And now in this viz, this tells a different story. The original one told the story of all these different categories all the same. This tells the story of a number of categories all similar and one that's special. And the reason that we provide so many different palettes and so many different options here is because we want you to be able to tell different stories with your data depending on what your message is. Now let's look at coloring for value. Here I have a map, and I've colored it by sales. And let's look at some of these controls for editing. When you assign a range, we've got from 3,000 to 1,000,000, what I do is I linearly map these numeric values into the color values. But we can see from the map that these are not uniformly distributed. We have a few dark ones and a lot of medium ones. We can try stepping the color to get a better sense of binning these categories. And this makes it easier to see the individual colors, but without the subtlety. We've now lost a lot in the Midwest here. So there's unstepped, there's stepped. And we can also reverse the color if we wanted to emphasize the low values instead of the high ones. We have a lot of different color palettes, color ramps in this case. And so we can assign an orange one. And this orange one has some of that nice hue shifting in it that you saw in the Netflix ones, because it's running through color name boundaries from brown to orange. Another thing when you're doing this kind of visualization that affects the appearance of the color is how transparent it is. And what color the outlines are. So that looks quite different than that or that. We also let you, as well as selecting colors, create your own colors. Once again, you can get into the color picker and create whatever chaos you like. And so now I've got a nice purple one. If we changed what we're encoding by to profit, we now get a two-color ramp, like I described before. And here we have a few more controls. Again, if you step your ramp, if you do an even number of steps, then we get no gray in the middle at all. The question of whether you want to see this zero value or whether you want to see the region around it, where we get some sort of grays in the middle. And we can change our center from being 0 to maybe we're mostly interested in things that start at 1,000. Let me show you the last bit of controls here on the bars where it's a little easier to see. So notice here that what we have is an asymmetric coloring. We have an asymmetric set of data. We have only a little bit of negative but a lot of positive. So what am I going to do with this two-color ramp? I have two choices. One is that this bar is about as colorful as that bar of the equivalent length. But if I really want those negative ones to a pop, I can say use the full color range, and now I make this bar the same as that one in terms of the colorfulness. So here's just one more quick example. Here I've colored this bar chart broken down by, again, the regions and now by the, again, our familiar categories. If I take this over and turn this into and I've colored the bars by profit, and I turn this into a table, by default we color the text, but that's not often the best way to show colored text, a colored highlight table. It's better sometimes to create a background, what we call a highlight table, and in this case what we probably want to do is use one of these colorings with the white in the center. It's cleaner and easier to see. I didn't really need all that gray telling me that those were not special values. What I'm doing is I'm emphasizing the ones that are out of range, to the extremes of the range. All right. Apologize for the bobble. Let me get back to the slides now, talk just a little bit about colorblindness. And let's see.
Here, I'm going to help you out. I just pushed the slide, so you should be up there.
All right. Here we have in summary. We have identifying the function. That's your first rule. This is now about designing data before I switch into colorblindness. Focus on the data. Contrast is important and aesthetics are important. We do try to make the colors in Tableau aesthetic, the kind of professional looking colors that you would not be ashamed to show in front of your board. So what about color blindness? Most people who are colorblind, and this is about 8% of men, is the most common kind, have a weakness in the red-green discrimination, and I've got a simulation here in the lower right corner. So they can still see some degree of red and green, but not as strongly. There are people who are missing a cone entirely, and here they have this two-dimensional color space that's all grays and oranges, and it turns out also blues. And there's different forms of colored blindness depending on which cone is affected. The real challenge of color blindness for color visualization is not so much red-green, although it's better not to depend on that. It's how it changes the mapping to names. People with CVD can't see small amounts of red or green, so that shifts blue and purple into the same color. It shifts gray and brown into the same color. Interesting enough on displays, because the yellow is very greenish, one of the most common problems is a collision between orange and green. And it's these distinctions, not the pure red-green ones, that are the challenge for CVD. So as a rule of thumb, blue, orange, and gray are safe. Most people can see them. They won't see them in exactly the same way, but they can discriminate them as separate colors. We have in the Tableau 10, and we have fairly strong colors. That's good for people with weak color vision. So with mild CVD, they're still somewhat distinguishable. We're starting to lose some of it. And we also, for severe though, they're not good enough. So we provide a opportunity in Tableau to double encode. You can use both shape and color. And in general, if you're going to design, again, we're back to the shape and shading. If it's really important for it to be distinctive, don't count on color alone to make it distinct. And we also provide a colorblind palette. So in conclusion, our goal is to work with the visual system. Color is secondary to lightness and contrast. I taught you to create a visual hierarchy and to use color for a specific function. And please don't forget those with CVD. Do your double encoding or use colorblind safe colors, or at least provide an option to switch into a mode that's more color vision friendly on a universal level. And so that's the end of my story. Thank you very much, and Tim will field questions.
Very nicely done, Maureen, and you did a very good live presentation. Those are not easy to pull off.
Well, modular, I'm if there's time, I'll go back and see if I can figure out what the heck's wrong with it. But
you did fine. So while we're at the Q&A portion, I have up on the screen Maureen's contact information. So if you have questions that you'd like to reach out to her after today's webinar, her information is there, and you can do so following today's event. So we do have some questions that came in. Thank you to the audience for participating. The first question is, how do you use the Lstart concept in Tableau? Can you go into a little bit more detail there, Maureen?
Yes. When I design the colors in Tableau, I design them in a combination of visually and metrically. And for metrics, I use the CIE lab space. I start usually sketching around in Photoshop, but ultimately I have a bunch of analytics written in Python that compares the metrics like the CIE lab values. Excuse me. One of the things I've noticed, and one of the things I've actually even written about in an article, is that when you do categorical coloring, it had been the sort of rule of thumb in visualization that you didn't want to change the lightness value much, that there was a worry that you wanted just to change hue. And I've just, that way you don't ever risk getting any sort of pop or pre-attentive distraction from one color being lighter than the other. But I found that for the colors to work well categorically, they do have to expand over a range of lightnesses. I have a range for Lstar values that I tend to use between like 40 and 90. And 90 is a fairly light color. That's about the minimum you can get away with for legible text. So I use it for text legibility. So it's not just a matter of saying, well, is the color pretty? I actually go ahead and set it to be sure that it's contrasty enough to actually make the text readable. So at this point, it's all used in the design. It's not actually used in the product itself.
Okay, excellent. Very good answer there. Another question that relates to the Lstar is one of the viewers wants to know if you have any Python module for the Lstar calculations, or if there's some code that you might be willing to share, like the GitHub kind of thing.
Well, I could if people want, but if you're working on the web, the D3 library for JavaScript has a perfectly good Lstar CIE lab implementation. What you'd be looking for if you're web searching for the code is CIE lab. There's a tool called GPIC, which is an open source tool in C++ that has it. And I'd be happy to share my little Python module if you like. The math is not very complicated. Wikipedia has a good example of a description of it, of course. But if you'd rather, as I said, if the D3 library won't work for you, then sure, I'd be happy to share the Python code.
Okay, that's very kind of you, and anybody that's interested can reach out to Maureen directly with the email. Somewhat related to this notion of resources, another question is, other than tough seminal works, what other books would you recommend to help us understand data visualization design and visual perception, sort of the relationship between the brain and the visual cortex? Are there other resources that you can recommend?
Oh, wow. I will put a small plug in for my book, although it has a lot of the basics. The bulk of the book, though, is more about color imagery production, which is the field I was in before I got so much into functional color. Margaret Livingston has written a wonderful book about color and vision that if you really want to know, she's how the brain works, that would be the one I would recommend. If you're really interested in coloring like on maps, Cynthia Brewer, who has also written an online tool called the Color Brewer, does a wonderful job of telling you how to use color in map visualizations, and actually will offer you color palettes online. Color Brewer is the thing you should type in if you just want resources for actually doing the design. Yeah, I'd need to know. I've got lots of books. That is another plug in my book. I've got a bibliography in the back of a lot of different resources. Okay. But again, you can reach out to me if you have a more specific question.
And just to give you a proper shout out, your book, as I mentioned at the beginning, is A Field Guide to Digital Color. So everyone can look that up.
Available on Amazon like everything.
Okay. Excellent. The next question is, since we have members coming from all over the world, I think this question has some relevance, which is how important are cultural differences in color encoding?
So the cultural differences come in not in terms of like the basic coloring and the basic names, but they come into more the semantic and the aesthetic encodings. So if you had a cultural preference for a different set of categorical colorings than kind of the Candy Bright that I did, if you were making a viz that had a cultural semantic representation and you wanted to use red as a joyous thing instead of an alarming thing, that would be perfectly appropriate. And yeah, I think that's mostly where culture comes in. Also in the aesthetics, there's some indication that different cultures prefer things to be boldly colorful, whereas others prefer them to be more subtle. Okay? Are you there, Tim?
Sorry about that. I had to unmute. My apologies. The next question is a quick one, I think. Everything you've shown, for the most part in your presentation, has been on a white background. What if you were to use a colored background or something a little darker palette?
Oh, good question. This issue of background, our visual system it actually works in a relative manner relative to the white. And so when people say, well, what about a white display versus a black display? I say, well, it's a little easier on your eyes assuming you have enough brightness overall and you're not sitting in the dark, to use a white background. So that gives you kind of a plane, like a piece of paper to focus on, and then you pop the colors off of that. If you use a dark background, like a black background, like many apps do, that's okay too. If the black were completely and utterly black so that the objects kind of floated in space, that would be difficult. Mostly they're not. I prefer a dark gray if you need a dark background. One place that dark background is absolutely important for is if you're sitting in the dark, like at night and your GPS switches to a dark background or in a cockpit display, or if you're sitting in a dark room monitoring other things, you don't want the white glowing at you. But the perception of color is very influenced by what color the surround is. So if you make your background pink or blue or aqua, it's going to shift the perception of color dramatically. You saw it a little bit with the outlines just switching between black and white. I should have put a brown one on there, and then it would have looked yet a little different. So you can do it, but you have to be fairly cautious, because once you start changing the background, then the foreground colors will appear really different. And if your background varies, then the same color will look different in different parts of the viz, and that can be very distracting. PowerPoint styles that have gradients are awful for that, for example. It affects the text readability as well.
Okay, excellent. One question I want to make sure we get in today is, you've mentioned the 3 color dimensions, and it's perfect for, I think, a digital display and seeing things in a projected environment or on a screen. But as it relates to printing, how does that come into play with CMYK?
Yeah, so people say, I didn't emphasize it as much in this talk, but one of the things that you should know is that the color 3 is magical in color. Because we have 3 cones, there's a direct relationship between that and why we can use red, green, blue on our displays. However, in printing, we are actually using only 3 colors also, cyan, magenta, and yellow, which are color filters that modulate the red, green, and blueness of the image they reproduce. But because they don't go very dark, because filters are not very pure, we need to increase the contrast, and that's what the black is for. So all 4, 5, 6 color representations are really augmented 3s.
Got it. Okay, excellent. So that'll have to be our last question and answer. Thank you to the audience for some great questions. Maureen, you did a wonderful job. For those of you that did ask some questions that didn't get answered, all will be sent to Tableau and to Maureen. And again, you should have her contact information, and you can follow up directly with her. I have just a few quick announcements. Please mark your calendars for May 27th and our next Data Science Central webinar, Building a Customer-Centric Culture by Harnessing the Power of Big Data, which is sponsored by Actuate. Also, I mentioned that this is being taped, and you can find it on Data Science Central later on this afternoon. And this brings our webinar today to a close. I want to thank our audience again for attending and for some very thoughtful questions. And a special thank you to Tableau for sponsoring and our panelist, Maureen Stone, for her insight into today's topic. My name is Tim Madison. It's been a pleasure being your host today, and I look forward to seeing you all again on May 27th. Good day.